Hello students, welcome back to my YouTube channel Math Maverick. Today we start with class 10th Mathematics chapter 8 exercise 8.4 question number 5 6th part. कल क्वेश्चन नंबर 5 5th पार्ट तक कंप्लीट हुआ था, तो आज क्वेश्चन नंबर 5 6th पार्ट स्टार्ट करेंगे.
We will simplify the left-hand side, LHS, to equal the right-hand side, RHS. Step 1. Rationalize the denominator. The standard technique for square roots involving 1 pm sin A or 1 pm cos A is to multiply the numerator and denominator by the conjugate of the denominator. Here, the denominator is 1 minus sin A, so we multiply by 1 plus sin A. Step 2. Simplify numerator and denominator. Numerator, 1 plus sin A. 1 plus sin A equals 1 plus sin A squared. Denominator. Use the algebraic identity AB of A plus B equals A to the power of 2 minus B squared. So, 1 minus sin A, 1 plus sin A equals 1 minus sin to the power of 2A. Step 3. Apply trigonometric identity. We know that sin to the power of 2A plus cos to the power of 2A equals 1, which implies 1 minus sin to the power of 2A equals cos to the power of 2A, ZIND. Substitute cos to the power of 2A into the denominator. Step 4. Remove the square root. Since both the numerator and denominator are perfect squares, we can remove the square root. Step 5. Split the fraction. Divide each term in the numerator by the denominator. Step 6. Convert to reciprocal and quotient forms. We know frac 1 cos A equals sec A. We know frac sin A cos A equals tan A. Result, hence proved. Summary of formulas used. 1. Algebraic identity, a minus b, a plus b, equals a to the power of 2 minus b squared. 2. Square identity, 1 minus sin to the power of 2a equals cos to the power of 2a. 3. Reciprocal identity, frac 1 cos A equals sec A. 4. Quotient identity, frac sin A cos A equals tan A. Here's the step-by-step solution for Class 10 Mathematics, Chapter 8, Introduction to Trigonometry, Exercise 8.4, Question 5, 7. The problem, prove the following identity. Step-by-step solution, we will simplify the left-hand side, LHS, to make it equal to the right-hand side, RHS. Step 1. Analyze the LHS. Step 2. Factor out common terms. Observe that sin theta is common in the numerator and cos theta is common in the denominator. Let's factor them out. We know that frac sin theta cos theta equals tan theta. So we can write. Now, our goal is to cancel out the terms inside the bracket so that only tan theta remains. Step 3. Convert terms using identity. We need to make the numerator and denominator identical. We can change sin to the power of 2 theta to cos to the power of 2 theta using the first trigonometric identity. Substitute 1 minus cos to the power of 2 theta in place of sin to the power of 2 theta in the numerator. Step 4. Simplify the numerator. Expand the bracket in the numerator. Rearrange the terms in the numerator. 2 cos to the power of 2 theta minus 1. Step 5. Cancel common terms. Now, the numerator and denominator are identical. They cancel each other out. Result, hence proved. Summary of formulas used. 1. Factoring. Sin theta minus 2 sin to the power of 3 theta equals sin theta. 1 minus 2 sin to the power of 2 theta. 2. Quotient relation. Frac sin theta cos theta equals tan theta. 3. Square identity. Sin to the power of 2 theta equals 1 minus cos to the power of 2 theta. Here's the step-by-step solution for Class 10 Mathematics, Chapter 8, Exercise 8.4, Question 5, 7. The problem, prove the following identity. Step-by-step solution, we will start with the left-hand side, LHS, and simplify it to match the right-hand side, RHS. Step 1. Expand the squares. Use the algebraic identity, a plus b to the power of 2 equals a to the power of 2 plus b to the power of 2 plus 2ab to expand both brackets. Step 2. Regroup the terms. Rearrange the terms to group sin to the power of 2a with cos to the power of 2a and keep the reciprocal pairs together. Step 3. Apply trigonometric identities. We use the following 3 facts. 1. Square identity. Sin to the power of 2a plus cos to the power of 2a equals 1. 2. Reciprocal relation. Sin A times CSCA equals 1. 3. Reciprocal relation. Cos A times sec A equals 1. Substitute these values into the equation. Simplify the numbers. Step 4. Convert remaining squares to tangent of and cot. To match the RHS, we need terms in tangent of and cot. We use the Pythagorean identities. Cse to the power of 2a equals 1 plus cotto, the power of 2a secto, the power of 2a equals 1 plus tanto, the power of 2a. Substitute these into the equation. Step 5. Final addition. Add all the constant numbers together. 5 plus 1 plus 1. Result. Hence proved. Summary of identities used. X plus y to the power of 2 equals xto. The power of 2 plus y to the power of 2 plus 2xy. Sin to the power of 2. A plus costo, the power of 2. A equals 1. Sin A times C, S. Ca equals 1. And cos A times sec. A equals 1. C, S, C to the power of 2. A equals 1 plus cotto, the power of 2. A secto, the power of 2. A equals 1 plus tanto, the power of 2a. Here's the step-by-step solution for Class 10 Mathematics, Chapter 8, Exercise 8.4, Question 5-9. The problem? Prove the following identity. Note: the textbook often suggests simplifying the left-hand side, LHS, and right-hand side, RHS, separately for this specific problem. Step-by-step solution, Part 1. Simplify the LHS. Step 1. Convert everything to sine of and cosine of. We know that CSCA equals frac 1 sine A and sec A equals frac 1 cos A. Step 2. Take the LCM inside the brackets. Step 3. Apply Pythagorean identities. We use the identity sin to the power of 2a plus costo, the power of 2a equals 1. Therefore, 1 minus sin to the power of 2a equals costo, the power of 2a, 1 minus costo. The power of 2a equals sin to the power of 2a. Substitute these into the numerators. Step 4. Cancel terms. 1 cos A from the numerator cancels with the denominator. 1 sin A from the numerator cancels with the denominator. Part 2. Simplify the RHS. Step 5. Convert tangent of and cot to sine of and cosine of. We know tan A equals frac sine A cos A, and cot A equals frac cos A sine A. Step 6. Take LCM in the denominator. The LCM of cos A and sine A is sine A cos A. Step 7. Apply identity and flip. We know sin to the power of 2a plus costo the power of 2a equals 1. Substitute this into the fraction. When you divide by a fraction, you multiply by its reciprocal. Conclusion. Comparing our results from Part 1 and Part 2. Since LHS equals RHS, the identity is proved. Summary of formulas used. 1. Reciprocals. CSCA equals frac 1 sin AC. Sec A equals frac 1 cos A. 2. Pythagorean. 1 minus sin to the power of 2a equals cos to the power of 2a, and 1 minus cos to the power of 2a equals sin to the power of 2a. 3. Quotients. Tan A equals frac sin A cos AI. Cot A equals frac cos A sin A. Would you Here's the step-by-step solution for the final part of this question. Class 10 Mathematics, Chapter 8, Exercise 8.4, Question 5x. The problem, prove the following identity. Strategy. We need to prove that the first term equals the third term, tan to the power of 2a, and that the middle term also equals the third term, tan to the power of 2a. Step-by-step solution, Part 1, solving the first term. Step 1. Apply Pythagorean identities. We know the identities. 1 plus tan to the power of 2a equals sec to the power of 2a. 2. 1 plus cot to the power of 2a equals CSC to the power of 2a. Substitute these into the fraction. Step 2. Convert to sine and cosine. Recall that sec A equals frac 1 cos A and CSCA equals frac 1 sin A. Step 3. Simplify the fraction. When dividing by a fraction, multiply by its reciprocal. Since frac sin A cos A equals tan A. Part 2. Solving the middle term. Step 1. Convert cot A to tan A. To make simplification easier, replace cot A with frac 1 tan A. Step 2. Simplify the denominator. Take the LCM in the denominator. Step 3. Rearrange and multiply. Bring the bottom tan A to the top. Notice that the terms 1 minus tan A and tan A minus 1 are very similar, just with opposite signs. Factor out a negative sign from the numerator term, 1 minus tan A, so it becomes minus tan A minus 1. Step 4. Cancel common terms. Cancel tan A minus 1 from the numerator and denominator. Step 5. Square the result. A negative number squared becomes positive. Conclusion. From part 1 and part 2, we have shown 1. Frac 1 plus tan to the power of 2a, 1 plus cot to the power of 2a equals tan to the power of 2a. 2. Left. Frac 1 minus tan a, 1 minus cot a right, to the power of 2 equals tan to the power of 2a. Therefore, hence proved. Congratulations, you have completed exercise 8.4. Would you like
Thank you so much for watching. Bye.